All right, class. So I'm I'm going to call this a part 3 on the recording from where I left off from the second part. But we were talking about we had done our created a group frequency distribution by hand from scratch, and we had gone through creating the class limits and making the class boundaries, and now we were up to the tally part. And on the tally part, what we'll do is we'll start like with 112. So what you want to do is you want to use your you want to record like each data value within its respective class limit. So each data value should fall within a certain class limit, and you want to put a tally into which class limit it falls under. Okay, so the first one is 112. So if we look at 112 and you look at your class limits, 112 would fit right here between 110 and 114. Okay, so I put a tally for that. And then I'm going to go to 100. And 100 fits under the first class limit. See, 100 fits between 100 and 104. So I'm going to put a tally there. So you can either in your data you can either go across, which is what I'm doing. See, I'm going to go to 127, or vertically. So if you wanted to start this way, 112, and then 110, then 107, 116, 120, and then come back up here, and then continue all the way until you're done with your data. You could do that, okay? All the way till you get to 114. And then 114, you know, would fall under right here. 114 is the last data value, would be 114. Okay, so you can see from the bottom that the bottom is complete. See this bottom by here? So 114, that last data value, that would be this mark right there, reflective of that, this last data value. I'm going to go across this way, across, and then across, and then I'll probably stop about right here until I get to the last data, which is 114, which will still be marked here. Okay, so 127 fits under this class right here, 125 to 129. Okay, then I have 120. So 120 fits right here between 120 to 124. Okay, then I go to 134. So 134 fits right here between 130 to 134. Okay, then I go to 118. 118 fits right here between 115 and 119. Okay, then I go to 105. 105 fits right here, 105 to 109. Then I go to 110. So 110 fits right here, and this is like class 3, if you will. Class 3, 110 to 114 fits right there. Then I have 109, so that fits under class 2. See, 105 to 109. Then I go to 112. 112 fits within class 3, 110 to 114. Okay, then I go to 110, so I started my second row. 110 again goes under class 3, see 110, 114. So that has 4. Then I have 118. So 118 fits under class 4. Then I go to 117. That also fits under class 4, 115, 119. Then I go to 116. That also fits under class 4, 115, 119. Then I go to 118. And that also fits in a class 4, 150, 119. So finally get to 5. Okay, and that would be the idea. Then you would keep going. So when I have this on paper, it's helpful because see how I draw a line underneath it. The only thing is remember, okay, when you do your homework, what I recommend you do, it just takes a lot of your paper, but what I do give you the option to print your homework. That way you don't feel like you're glued to the computer the entire time. I do let you print. It just probably eats up a lot of your paper when you do that. But you see here how I have this on paper. I'm able like to underscore things so I don't forget where I'm at. If you work from a computer, you just are like maybe touching your screen. So like you're touching your screen like I got this number and then I got this number taken care of. So you're using, maybe you're touching your screen, your monitor, keeping track with your finger over the data. So it's kind of hard to keep track of that. Um, but you do need to do all your tallies. And you see when you're done, these are what your tallies look like. So then and then your frequencies, this would be a frequency of 2. This would be a frequency of 8, 5, 6, 7, 8. This would be a frequency of 5, 10, 15, 16, 17, 18. Okay. And so you want to continue that and finish that. Okay. This would be 5, 10, 11, 12, 13. Okay. This would be 5, 6, 7. So we have 2, 18, 2, 8, 18, 13, 7. And then these are just ones. Okay. And then you see on the next page, on the last page, on page 29, where we'll be done, almost done with this problem with the ideas, you can see how I was double checking those from what I had here. But we did do these here, frequencies here, okay? So I have my class limits, my class boundaries, my frequencies. And then now you're going to have this on your homework too. They're going to ask you about a cumulative frequency distribution, okay? Cumulative frequency distribution. So it says sometimes it's necessary to use a cumulative frequency distribution. A cumulative frequency distribution is a distribution that shows, let me highlight that. It shows the number of data values less than or equal to a specific value. Okay, so I'm going to highlight these numbers here. Usually it's when they say number of data values less than or equal to a specific value, usually there's referring to these lower class limits here. Okay. So what I'm going to do is I'm going to put these rows in. And this part, I've seen this in your textbook. That's why I'm going to write this in. To say how many data values were. And in this case, we would say here less than 99.5. And I got that from this number here. And then they're talking about like the original data. So if I go back to the original data, how many of these data values were less than 99.5? Well, there were 0 that were less than 99.5 because remember the lowest was 100. So you should kick off these cumulative frequencies. They should be kicked off with 0. So I will put the 0 here. Sometimes they'll put the 0 like up here at the top, which is fine. Or sometimes they'll put the 0 here, but you do want to, wherever they have it available, you just kick it off with 0. So I'm going to kick it off with 0. And then when I have my last value, I'll just have to put that in here and this value here. Okay. So I'll kick it off with 0 here. Now, the way you'll know if you're done is this will be the last value I record here. I'm going to tell you here that, let me just take these off. We won't need this. The way you'll know if you did it right is that this last grand total, it should equal the amount of data values we have. And I believe if we go back and count how many, I think we had 50. Let's see. Remember? The following data represent the record high temperatures for each of the 50 states. So 1, 2, 3, 4, 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So it should have been, we had 50 states and the record high temperatures. We had 50 states. I'm gonna do this. 50 states high. I'm gonna do this. We had 50 states. Put apostrophe here. 50 states high temperatures. 50 states high temperatures. Okay. So this should, when we're done, we should get, so you'll be able to check your work. When you do your homework problems, you can check your work, because before you actually hit like check it or next, is you should make sure this last number equals the amount of data. So this should be 50, and that's how you can check if you did it right. So just remember that when you do your homework, you can check that. So here we have 0, okay? And then this would be saying how many data values were less than 104.5, okay? So that's doing it the long way. I'm going to go back and check the data, how many were less than 104.5. But the quick way is you just use this. That's why I call it a cumulative frequency. Cumulative means is you add on, you add on. So the way we get this value is you add on this 0 plus this, which is 2. So we should have 2 data values that were less than 104.5. And you see that's what this says. See, 99.5 to 104.5. It shows that we have 2 of them. So yeah, if you were to go back and check the data, we should have 2 values that were less than 104.5. So see if we can find them. So less than 104.5. So that would have been 100. That's less than 104.5. Can't be this one. It has to be less than 104.5. So there should be another data value that's less than 104.5. This one, see, this is 104. That's less than 104.5. Yeah, and there should only be 2. And I'm looking at the other ones. Yeah. So you see there's your 2. Okay. And which marks that. Okay. And then we're saying how many data values are less than, and the next one will be 109.5. And so now it should be the total, see, 104.5 to 109.5. So it should be a total of 10. It's these 8 and this 2. So now when we add, we're taking this previous value, 2 plus this 8, which gives us 10. So 2 and 8 is 10. Okay. And so we should have 10 data values that are less than 109.5. So I can go back and let's find those 10 that were less than 109.5. So we've got the yellow, so we need 8 more. So see, like 109, that's less than 109.5. There's another 109. Here's 105. Here's 105. So less than 109.5. 106. So I have 1, 2, 3, 4, 5. So I need 3 more. It's 105. So let's 109.5. Here's 108, and there's 107. Okay, so there should be my 2 in yellow and then my 8 in orange. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so you see it checks out. It'll check out. Okay. Okay. So there's the orange and then the yellow. So then when you can, once you see that and you confirm that, then you get the idea. So then now this would be a total of 10 plus this 18, which would be 28. Okay, and the next cumulative frequency will be 28 plus now this 13. Looks like that would be 41, right? Okay, next we would have 41 plus 7, which would be 48. And next we'd have 48 plus 1, which is 49. And then we'd have 49 plus 1, which is 50. Okay, which is 50. All right. So do you see now that's checks out? Okay. All right. Now these here are extra math problems that you can work on. I usually don't in class time. I don't usually spend time on these. This is just extra practice if you want to do these before you start your homework. But in your modules, in your saved PDF notes, there should be one of those saved PDF notes related to your 2.1 workbook that does. I believe I have actually in the past have worked these out on my own and then put the key up. So if you want to look for that, you can in that quiz 1, or excuse me, quiz 2 is being the quiz 2 module that talks about 2.1. So you can look through that. But I usually don't spend time doing these in class. Those are like saved for extra practice before you do your homework, or after you do your homework, you can practice that. Okay, now what I did want to show you though for extra work is I did put some handouts out. I did put a handout up in your modules. Sometimes your workbook doesn't have all the variety of problems in your workbook, so I have to supplement. And what I used to do, like in the face-to-face classes too, I would supplement with the copies, but now we don't have, now because what's going on with the COVID-19, I can't even, we don't have face-to-face classes now, they're remote learning, so even I have to make these available for even the online students and the remote learning now. So I did put some copies of these up. Okay. So I'm going to, and it's because the workbook doesn't show you an example of the third type of frequency distribution. So if you don't have these copies printed yet, you can pause the video and then retrieve them and then restart the video when you printed them if you want to go along with me with the print sheet. But this is something I got out from the workbook. This is like this is actually from an ebook. This is a problem from an ebook problem. So towards the back of 2.1, this is still 2.1. You've got a problem that you should look for in your ebook. It's related to dogs. This was number 16, the ages of dogs. The ages of 20 dogs in a pet shelter are shown. Construct a frequency distribution using 7 classes. So again, they have to tell you how many classes they want. But the thing is, look at the numbers, how small they are. And this is referred to as the third type of frequency distribution. So the first one was the group frequency distribution when you have large numbers. And then the second one was the categorical one. So first we had the group frequency distribution, okay? We had large numbers. Then the second one was called the categorical frequency distribution, which had just variables, not numbers, okay? And then now when you have small numbers, this is called ungrouped frequency distribution. So it's used for numerical data when the range of the data values is relatively small. It's constructed using single data values, like only one unit for each class. So the first step is to determine the classes, the class limits. Okay, so we do the range, which is the high data value minus the low data value. So the high data value here is 9, and the low data value here is 3. So 9 minus 3 is 6. Okay. Since the range of the data set is small, then classes consisting of a single data value can be used. Use the number of classes arbitrarily chosen by the author, and they want it, see, by the author. So chosen by the author, they want it 7. So chosen by the author, and they want it 7. Okay, so when I start that here, class limits, I still start with this. So I still, under class 1, I still begin with the smallest data value, which would be 3. But then I just have 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9. And the reason why I know to stop at 9 is because I want to have 7 classes. So this is class 1, this is class 2, class 3, class 4, class 5, class 6, and then class 7. See that? Okay, so that sets that up. And then step 2 says that if the data are continuous, then class boundaries can be used, where we subtract from each class value ending in a 5 and one additional place value, then the class limit value, to obtain a lower class boundary. And to obtain the upper class boundary, we add the same value to the class limit. Okay, so yeah, so we kind of know about that. So here I had that 3. So then this class boundary, I'm basically doing 3 minus, because that's a counting number. I'm going to do 0.5, and then 3 plus 0.5, because I only have one number here. If I had, you remember how we did this in the past? Remember, if I had this kind of a class limit like this, then I do subtract and add, subtract here, and then add here. Remember? But in this case, I only have 1, which is kind of what we had in quiz 1. When we take quiz 1, that problem related to the boundaries, you'll have 1 digit and you're going to subtract and add. So if I do 3, take away 0.5, that's 2.5. And then 3 plus 0.5 is 3.5. Okay. And for 4, I'm going to do 4 take away 0.5, and then 4 plus 0.5. So 4 take away 0.5 is 3.5, and 4 plus 0.5 is 4.5. Okay. So what you could do at this point is, if you wanted to, you could stop the video now, stop it, and then you could do the rest of them. And then you could turn on the video when you're done, and then we can check our work. Okay, so you could do, that's just an idea. Okay, so I'm going to write down the rest of these now. Okay, so for 5, I have 4.5 to 5.5. For 6, I have 5.5 to 6.5. For 7, 6.5 to 7.5. For 8, 7.5 to 8.5. And then remember the last one, 9, 8.5 to 9.5. Okay. And then the tallies, what we'll do for the tallies. So the tallies, I go to my data, okay, and and I see my first data is 5, and then I have an 8. So the 5, I'm looking at my class limits. So you want to, the tally is, remember what we put over here for the tally. Record each data value within its respective class limit. Same thing. Record each data value within its respective class limit. Okay. So not to confuse it with the class boundary, not to confuse it with the class boundary. It's within the class limit. Okay. All right. So then if I look at the 5 and the 8, 5, see if it's here, 8 here. Okay. Then I have 7, 6, and 3. So 7, 6, and then 3. Okay. And then I have 9, 4, 4. So 9, 4, and then another 4. Okay. And then 5, 8. So 5, 8. Okay, then 7, 4, 7. 7, 4, 7. And then 5, 7. 5, 7. Okay, 3, 5, 8. 3, 5, 8. And then 4 and 9. 4 and 9. Okay, so when I count now my frequencies, this is 2, 4, 4, 1, 4, 3, and 2. Okay, so 2, 4, another 4, 1, 4, 3, and 2. Okay, and then if I double check how many total is that, if I were to add all those up, that would give me, if I do this, summation of F, that's a summation symbol, Greek letter summation, sigma, summation of F for frequency, that would be a total of 20. And so, yeah, remember it said that we had 20 dogs. So you just want to make sure you didn't, on your tally, you didn't omit any, okay? Okay, then there's one more thing to do on the next page. Let's see. Okay, summation of F, okay, summation of F, okay? This is called summation, which is that's a Greek letter sigma. Greek letter, this is called like a sigma, okay? Greek letter sigma. Later on in chapter 3, there's a handout that you can print that I have in your, say, PDF of all the Greek letters of the alphabet, and because you're going to use that quite a bit in chapter 3, but that's the Greek letter sigma. Okay, so then now come over here. Okay, so we already did the tally. Record the numerical frequencies from the tallies. Okay, we already did that. Okay, then they say that you can talk about the peaks. You can make a statement about the peaks, the highest numbers. So for us, our highest numbers was 4. The lowest number was 1. So you could kind of call these 4s a peak. And then this 1, you could call that like an outlier. So you only have 1. The lowest number only appears once. And so they're saying that you could make a comment about the peaks and a comment about the outliers. So if you look at the peaks, the ages, these were ages of dogs. You have 5, 4, and then the age of 7. So I said something like that, that among the 20 dogs in the pet shelter, most dogs were ages 4, 5, and 7. And then what I said about the outlier, the one that had 1 was for age 6. So I can just say something like only 1 dog was age 6. So your book talks about how you can make comments and statements about peaks and outliers, okay? Okay, next it looks like we're going to do another little cumulative frequency, just like we did at the end of the other group frequency distribution. And remember, this is called an ungrouped frequency distribution. They also have a cumulative frequency on that. Find the cumulative frequency distribution, and I have CDFs. I meant to say CFD. If I'm going to take a shortcut, CDF. So I should say CFD, cumulative frequency distribution for the data. CFDs show the number of data values that are less than or equal to the lower class boundaries and the last upper class boundary. Okay, so see how I listed less than 2.5, less than 3.5, kind of like what I did on the other problem. So if I get my yellow highlighter, 2.5, 3.5, 4.5, see where I'm actually getting those from. Actually, I can just like I did in the other sheet, can highlight all of those. I can also highlight all the lower class limits. Okay, they also say it, the lower class boundary, and then the last upper class boundary. Let me see, the last upper class boundary. Let me see if I highlighted that in the other page. Let's see. So I just highlighted the 99.5, and then it looks like I should have also highlighted, according to this, it says the lower class boundaries and the first and the lower class boundaries and the last upper class boundary. So yeah, it should like I should have highlighted this and then also highlighted that is what they're saying. And remember how I was making comments about that? That's what they're referring to these here. Okay, so that's why here, let's see this one. So 2.5, 3.5, 4.5. Yeah, so I'm getting, and then it has 9.5. Yes, so it's all these lower class boundaries and then this last upper class boundary. So remember, these are lower class boundaries, and then upper class boundaries. Yeah. And these are class limits. There was also a lower class limit and an upper class limit. Yeah, so we've said before, these are lower class limits, upper class limits. These are lower class boundaries, upper class boundaries. Okay. 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 So then again, when I kick these off, I always kick it off at 0. Okay. And I'm gonna do this cumulative frequency. And remember, when I'm done, this last number, when I'm done, the last number should reflect 20. So remember, the last number in your cumulative frequency should reflect the amount of data. And remember, we had 20 dogs, right? So when you're done, you should have 20 dogs. Okay. So then when I go back and start off with 0, and I have to go back and do my frequency. So 0 and then, see, 0 and then 2. So 0 and then I'd have 2, and then I'd have, see this, then I have 2 plus 4, which would be 6. So 6 is coming because you have the that 4 plus this 2 here. Okay, and then next we'd have another 4 to add to that. So you're adding another 4 to this 6. Okay, so you can talk about this 4 here. So 6 and 4 is 10. Okay, then you're going to add 1 to 10. So that gives you 11. So that's that 10 plus that 1. Okay, now I'm going to add 4 to that. So I'm going to have 11 plus 4, which is 15. Okay, then I'm going to add 3 to that. So I have 15 plus 3, which is 18. Then I'm going to have 2 to that. So 18 plus 2, which is 20. So you see? And that should, remember I said that, how do I know if my last number is correct? What do I end with? End with 20. Okay? All right. Yeah, so then this, you know, you just want to make sure you have enough, like where do you start your 0? So yeah, the 0 does start off with the less than 2.5. And then when you have that list 9.5, that last one, there's your 20 off of that marker. Okay. 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 And then the last thing I want to show you, there's another page that if you printed this, you also got this in your printout. And I was going to show you some of these because in your quiz, when you take your quiz number 2, you're going to have one problem, and you're going to do this in your homework too, but you're going to have one problem like 9, 10, 11, and 12. You're going to have one problem on your quiz like this, where you want to, you have these frequency distributions. These are group frequency distributions. So show, these are called grouped frequency distributions. And there's something wrong with them that are incorrectly constructed, but then they want you to state the reason why they're wrong. So the reason why they could be wrong is either you want to ask this: are the class widths uniform? Okay, so remember, the way you do that is you're not doing these from scratch. So you're not going to use this formula here where you do it from scratch. You're not doing it from scratch where you have the width, the range divided by number of classes. You're not creating from scratch. These are already created, but you're going to subtract vertically using a pair of lower class limits or a pair of upper class limits. Okay, so remember I showed you how to do that. Okay, so that's one thing you have to check. And also, if you do it and you check these and they're all the same, they're all uniform, they're all the same. Uniform means, are they the same? Okay, and if they are you should do the lower ones first. And if they are, you still need to check, because sometimes the error may not be in the lower ones. If there's an error, it might be in the upper class limit. So you should check the lower ones first, and if they're all correct, the same class width, then you should also inspect this side to make sure they're the same, just to make sure that's not where the error is at. But that's one of the errors. The other error could be, do the class limits overlap? because you don't want them to overlap. So like if remember we talked about if somebody were 20 years old, you're not allowed to mark that person who's 20 in both the first and second or both in both class limits. You can only record the data once. So do the class limits overlap? So we want mutually exclusive. Okay, and then the last question to ask is, are the class limits continuous? Are the class limits continuous, or have some been omitted in between? Yeah, so remember we said that um, only, in your class limits, if you ever have a frequency of these that's 0, that you can only omit them if they're either first or last. But if they're in between, you shouldn't be skipping them like that. So that's what that's talking about. Okay. So let's see. So we go back to these and we look at number 9. Not sure where to put this. So we look at number 9. Let's see. I'm not sure where to put number 9 at, but so if I look at number 9 and I'm checking the class widths for number 9. So y'all can look at your number 9 there. And I'm going to start with 33 take away 27. And 33 take away 27 is 6. Okay. And then I'm going to do 39 take away 33. So you have to show this in your work. If you don't show this in your work, like on your quiz, then you will get points taken off. Even if you get the answer right, you don't show your work. And you have to show your work correctly. If you subtract like in some other manner that's not correct, we said you have to subtract vertically up and down, then you need to subtract the correct way, vertically up and down, okay, for these class widths. So 9 minus 3 is 6, okay? Okay, then if I do 45 minus 39, that's also 6. And if I do 50 minus 45, so you see right there how I have an error? There's an error right there. So there's no need for me now to check the other side, to start doing the other side, because I already found an error right here. There's an error. And so this tells us that the class width for number 9 is not uniform. Okay. And that would be one reason for that. Um, as far as the class limits overlapping, I don't see that happening here. The class limits overlapping, see 32, 33, 38, 39, 44, 45, 49. Doesn't look like they're overlapping. And as far as are the class limits continuous or have something been omitted? Yeah, so I don't think anything was omitted. See, like this is 0 and they didn't omit that. Like they didn't jump from 32 all the way to 39 to 44 just because that was 0. So yeah, they didn't do that. Okay. Okay, so that's the only reason why 9, that's the reason for number 9. Okay, if I look at number 10, and I start with if I start with the class width, just start with that first. Again, I'm going to subtract 9 minus 5 is 4. 13 minus 9 is 4. 17 minus 13 is 4. 20 minus 17. Uh-oh, that's 3. So you see that's an error. So right there, that's showing that the class width for number 10 is not uniform. Okay. Okay, now if I also look at other examples, anything else wrong with that one? It looks like the class limits overlap. See how if I had a data value that was 13, see if I had a data value that was 13, I would have to put a tally here. You know, I'd have to put a tally. Let's say that I had data of data value of 13, I would have to put a tally here for that 13 and a tally there, and that wouldn't be correct, right? And so we're going to say here that the class limits for number 9, the class limits 9 to 13 and 13 to 17, that they overlap for number 10. So you see, if that happens on your quiz, you have your template. When we take quiz number 2, you'll have a quiz template. So if that's the reason, you need to also show your work. So you need to write me a sentence. Just because you check that off, you have to specifically tell me where the class limits overlap. So it's the 9 to 13 and 13 to 17 where they overlap. And then also, they also overlap. They also overlap in that overlap in several places. They also overlap in the 5 to 9 and the 9 to 13. So the class width for number 10 is not uniform. The class limits 9 to 13 and 13 to 17 overlap for number 10. Okay. And that'd be fine. That you just have to specify one example. They do also overlap. Again, they also overlap. Also, they overlap for 5 to 9 and 9 to 13. So there's actually, repetitively, but that'd be fine. You're giving me at least specifically an example where they overlap. That's fine, okay? Okay, and as far as are the class limits continuous or have some been omitted? Yeah, so I don't see where that would fall into effect for that. Let me see if I can find one where that's happening. Let's see. Look at 11 and 12. Can you look at 11 and 12 on your papers? Let's see if that's happening. I think on number 11, do you see that happening on number 11? So on number 11, it looks like the class limits are the class limits continuous or have some been omitted? It looks like for number 11, it looks like class limits have been omitted. Okay, so let's see, for number 11. See, it looks like from 128 to 132. Look at 128 to 132, and then look how it jumped from 138 to 142. See that? So if I look at the class width would be for 11. If I do 128 minus 123, which is 5, looks like the class width is 5. If I do 132 minus 127, it looks like it's 5, right? If I do this side and subtract. So it looks like here I should have had, 128 plus 5, which is 28 it should have been 133, right? This should have been 128 to 132, and then look, after 132 should have been 133. And then if I add 5 to that, 133 plus 5, then it would have been 138. Yeah, so it looks like class limits have been omitted. And if you look right here, it's where it should have been 133. And now that I know the class width is 5, 132 plus 5 is 137. Yeah, 137. And then 137 plus 5 is 37, 142. Yeah, so can you see that? Looks like there was something omitted there. Okay, so on number 11, that would be an example where the class limits have been omitted. Okay, and then you could also say that let's see, there's a gap. Yeah, and I don't know if they want you'll have to see when you do your homework. Do they want you to mark all of them? State the reasons why they are wrong. So, I mean, because obviously when you're doing the class widths, also the class widths would be erroneous, because if you do the way you look at that here, if you were to on your class widths, if you were to do for 11, I did 128 minus 123, and then if I go to 138 minus 128, see, that gives you a 10. So in a way, that also makes the it also makes the class widths not uniform, meaning not the same. But it's mostly because this is causing that too, right? Because this is the main reason that the class limit has been omitted. Or the class limits continuous, or have some been omitted? So it's not continuous. It's not continuous. The class limits have been omitted. Okay. The class limits are not continuous. Okay. All right. Okay. And then one last thing I'm going to show you, and I'll be done. One last thing to show you is if you look at 5, 6, 7, and 8, if you just look at those, I'm going to do one problem from those. It says find the class boundaries, find the midpoints, and they want you to find the widths for each class. Okay. So the class boundaries, what I'll do for the class boundary is I'll do it for number 7. So number 7, I'm going to say find the class boundaries. So we have 8.24 to 11.36. These are in the hundredths place. So I need this to n of 5, and I need 1 decimal place beyond the data, beyond the class limits. So that means I need, if this is tenths, hundredths, that means I need thousands. So that means I need to subtract and add 0.005, tenths, hundredths, thousands. So this is 8.24 minus 0.005. This is 11.36 plus 0.005. Okay, so 8.24 minus 0.005 is 8.235. Okay, and then 11.36 plus 0.005 is 11.365. 11.365. Okay, so that's your class boundary for number 7. Okay, so if uh, if you look at some of my saved notes, um, I might have done some for. No, it looks like I always do number 7. I think I always do number 7, but this is just like a practice. If you wanted to do the other ones, you could practice. In your ebook, you should have, I think all the odds to your ebook are, you have an ebook, and I think you have at the back and like an appendix and an answer key. So I think all the odd answers are provided. So if you wanted to do like I guess 5, for example, you could and be able to check your work on that. Okay, but I just worked on 7. It happens to be an odd number. Okay. um Okay, now let me go now to another problem, 8, and let me just do the midpoint for that one. We're supposed to find the class boundaries and the midpoints and the class widths. So let me just now go to 8, and for 8, let me find the midpoints. Okay, so what I could do is I could add xm for mid, let me do this here, xm for midpoint. I could take the lower class limit plus the upper class limit, and I could add those up and divide it by 2. Now, if I wanted to check my work, I could also I have to do the class boundaries anyway, but then I could also check my work, and when I do the um, midpoint, I could do the lower class boundary plus the upper class boundary. I could add those up and divide by 2. Remember we did that? So I'm going to just use, for number 8, I'm going to use, so I did something in 7, I did something 8. I'm going to, these are called class limits. All of these are class limits. I know they're class limits. They're not class boundaries because, well, first they're telling you to find the class boundaries. If they were being class boundaries, they would have to all ending in 5. And you see, they don't, they don't all end in 5s. Okay. So I would take, for number 8, I would take parentheses 16.3 plus 18.5 and then divide that by 2. And you'd have to use parentheses. So the parentheses are right above the 7 and 8. Sorry, I'm using my TI-30X today. Sorry. So I'm doing parentheses 16.3 plus 18.5, close parentheses, divided by 2. 16.3 plus 18.5 divided by 2. 17.4. Okay, so that would be my midpoint. Okay, you need the parentheses. If you try to type it in without the parentheses, you won't get the same answer. Okay. All right. So, okay, so now let me show you. I almost got my paper full here, but I need to show you now the widths, how to find the widths. So I already showed you an example for a class boundary, and I already showed you midpoint. Now I have to show you something for the width. Okay, so um, I guess I'll do 6 first. I'll do 6 here. So if I'm going to find the width for 6, find the width. Okay, so I have here 125 to 131. Okay, so usually, I would subtract up and down, but see, I don't have this number here. So in order to do that, I need that number here, and then I could subtract these to find the class width. Now I do have this though. So remember I said the way we got that is like if I had known what this is, I would have gotten this by subtracting 1. So I would have said this number minus 1. gives us this. So it should be able now to work in the other direction. I should be able then to say that I'm going to add 1. So to get to this direction here, I can say I'm going to add a form of 1. Okay, so this would be 131 plus 1, which is 132. 132. Okay, and then to find the class width, I would subtract. So then the class width would be 132 minus 125, which is 7. Okay. Okay, and I'll do one more. I'll do number 8. So I'll do the class width on 8. So on 8, we have 16.3 to 18.5, and I want to find the class width. Okay, so I need to find this number right here. Okay, so again, I'm going to take this 18.5 and I'm going to add a form of 1. So I'm going to add a form of 1, and it has to have with the same place values. Okay, so this is going to be 18.5 plus 0.1. Okay, whereas this one was plus 1, because these are counting numbers. These have decimals to the tenths place. So this is plus a form of 1, but it has to be tenths place. So 18.5 plus 1 is 18.6. So this is 18.6. Okay, and now to find the class width. So now the class width is 18.6 minus 16.3. So 18.6 minus 16.3 is 2.3. 2.3. 18.6 minus 16.3 is 2.3. And that is your class width. Okay, class width. All right. Okay. So if you have questions on these, remember we have our tutoring center, MathWorld, and our president of our college has wanted MathWorld to stay open via Zoom virtual meetings or tutoring sessions. So in my Canvas course, for the main course, I have the link for MathWorld. And so if you have issues with this, you can share. I think they have it set up to where you can share your screens, where like if you have Connect Math open, you're working on your homework and you're stuck, you can share your screen. So they have that feature. What you would do when you share your screen, let's say I think they would make you the host. You have those little 3 dots. When you do a Zoom meeting, you have those 3 dots. They would have to go to those 3 dots and then like make you the host, and then you would share your screen. So at the bottom, you would see share on the bottom of your Zoom meeting. You'd have at the bottom share. You would hit share, and then I think it's basic, and then share screen. So you see these little prompts that say basic and advanced. When I use the Apivo, I use the advanced, and I do the document camera for advanced, but you don't have a document camera, so you do basic, and then you click on share for the share screen, and you look for your Connect Math and you share that screen. Then they can look at what problem you're looking at, where you're stuck. And then yeah, and then there's a chat, so you could to express your problem too, you probably could do some chatting on that. Of course, you talk about it. And then, I have these saved notes. So these are already saved PDF notes. So you can also, if you wanted to share that screen, your Canvas course, have 2 windows open, your Connect Math, and then have another screen open, your Canvas course, where if you wanted to share something in a saved PDF, you can go to my saved PDFs, and there's like, you see where she's writing here, where she's talking here, she's saying, I don't understand how she's figuring that. And then you can share the screen. They can take a look at that and try and make headway on that. Okay. But the tutors, that's what they do. Of course, you go to a stats tutor. Make sure you look at the tutors and what they teach. Don't go to someone who's not assigned your stats course. Go to somebody who's assigned to tutor stats. Again, the go-to person is Gertrude. Her Trudy, Gertrude, or go by Trudy. Um, she is our go-to person in Math Row. Um, so her first name is Gertrude, and she goes by Trudy. But she is the go-to person for statistics. And Mrs. Hurd, her last name is Hurd, I believe, Mrs. Hurd, Gertrude, and so go by Trudy. And because she has actually sat in the statistics courses, like in my class, in Mr. Trotman's class, some of Cindy Katz's class. So she sat in there, and that was part of her job. She got paid to sit in our classes so she could listen to us lecture. And then when we do the calculator, she would walk around and help us, the students, with the calculator when we did the days of calculator work. But she has done that. She has sat in my class more than probably 2 semesters. But that's why she's the go-to person, because she's the only one of the tutors who's got that experience, who's actually done that. So she's the first go-to person. And unless she's occupied, then you have to go with someone else, like Miguel. I think offhand Miguel is a go-to person, and I think also someone by the name of Mike, if he's still working. Someone by the name of Mike is another go-to person. Um, One of the other tutors, Roseanne, she used to teach statistics at a high school, at a private high school. So Roseanne is another person. And I think there's a Deborah Gaitan. Deborah is also pretty good. I don't know what her background is, but offhand, those would be the person. So person is like Trudy, Miguel, Mike, Deborah, and Roseanne are the people that come to mind. But they're like your people, your tutors to help you, because that's what they do all day. All day they tutor from home, but they're available to answer your questions. Okay. All right. So that concludes my video recording. Okay. So y'all can work on 2.1. Okay. Good luck with that.